potential energy of a dipole potential energy of a dipole.
Yes, sir.
Okay.
Yes, sir.
Now, in case of dipole in uniform field,
Yes, sir.
the potential energy is defined as the work done in rotating the dipole from the direction perpendicular to the field to the given direction.
Yes,
Okay.
sir.
Let's say what we can understand from that is now consider a uniform electric field.
Yes, sir.
Okay. Equidistant electric field lines denote a uniform electric field.
Yes, sir.
Okay. So now I'll write this. Okay.
Yes, sir.
Now this like this I will write this is P cap. What does it mean? This is minus Q
Yes, sir.
and this is
Plus Q.
plus Q.
Q. Yes, sir.
Okay.
Yes, sir.
So now it is theta is 90.
90.
Okay. So now if I make it to an angle theta,
Yes, sir.
then I call this as the work done is nothing but the change in potential energy that is equal to PE into
Cos
initially it is cos 90
90.
minus
Cos theta.
cos theta.
Theta. Yes, sir.
Okay, so that is equal to
Minus
PE into cos 90 is
0.
0
0 minus theta. Cos theta. Yes,
cos
sir.
theta. So that is minus
P cos theta.
PE
Cos theta.
cos theta.
Theta. Yes,
So
sir.
I will write it as minus P dot E.
Yes, sir.
Okay, so this is, see, look here electric field is doing work. So that's why we got minus.
Yes, sir.
Okay,
Yes, sir.
so work done or potential energy is equal to minus PA because it is work done by the
Electric field.
electric field, not
Yes,
work
sir.
done by the external force. It
Force.
is work
Yes.
done by the
Electric field.
electric field.
Yes, sir.
Okay,
Yes, sir.
right. Next concept is this is PE of dipole, right?
Yes, sir.
Next concept is equilibrium of dipole. Okay, so equilibrium of dipole means say this is electric field. This is electric field
Yes, sir.
and this is dipole.
Yes, sir.
Okay, that means dipole is placed like this, my negative and positive. Okay,
Yes, sir.
instead of drawing all the electric field lines and placing the dipole, I am just drawing it like this. You understood?
Yes, sir.
Now, here theta is equal to 0. Theta is equal to 0. What does
Zero.
theta is equal to 0 mean for me? Theta
Yes,
is equal to 0 means because P and E both angle between them
same
to both
direction.
are vectors. The angle between them is 0. That means actually it is like this. This is minus Q. This is plus Q.
Yes,
Okay,
sir.
that is a dipole.
Yes,
Okay,
sir.
theta is equal to 0. Then we say that is in stable equilibrium.
Yes, sir.
Stable equilibrium.
Equilibrium.
Okay.
Yes, sir.
Now here Okay.
Yes, sir.
If theta is equal to 0, or else the dipole is placed in electric field, it is said to be in stable
Stable
equilibrium.
equilibrium. Yes, sir.
Okay, because stable equilibrium means if I move it slightly and leave, then again it will come back to this position.
Yes, sir.
So that's why I call this as stable
Stable equilibrium.
equilibrium. In stable equilibrium, it will try to align itself
Yes, sir.
again in the direction of electric field. If you slightly move it like this, then again it will come back to its original position. That is called as stable equilibrium.
Yes, sir.
Here, the torque will be equal to 0
Zero. Yes, sir.
because torque is equal to Pe sine theta. P and E, the angle between them is 0.
Zero.
Pe sine 0 is
Sin zero
0.
is
0.
zero.
So torque is equal to 0. In the
Yes, sir.
same way, if you calculate work done, the work done is equal to
Zero.
0.
Yes, sir.
And potential energy is minimum, and that is equal to minus P,
P
because
cos
P
and yes, sir.
P cos P
Cos
cos
zero.
theta is equal to 0. Cos 0 is
One.
1.
Yes,
So
sir.
that is minus P.
P.
And maximum value of cos theta is 1. So U minimum is minus P.
P. Yes, sir.
Now, now electric field, you take electric field in this direction.
Yes, sir.
Okay. And uh, P in this direction.
Yes, sir.
P in this direction. What is the angle between them? Electric dipole moment and E.
90, 90 degrees.
Theta is equal to
90 degrees.
90.
Yes, sir.
So you're right, theta is equal to 90. So
Yes,
now this is not a stable equilibrium.
yes,
Then
sir.
I will calculate torque. Torque is equal to
P sine
PE sine 90. Sine 90 is 1. So
1.
this
Yes,
is this
P.
is torque is equal to P.
P.
Then
Yes,
what
sir.
about work done? Work done is equal to P.
P.
Okay.
Yes, sir.
And potential energy U is equal to P
Minus
minus P cos 90. Cos 90 is 0.
0.
So U
Zero.
is equal to
0. 0.
0.
Yes, sir.
Okay.
Yes, sir.
Now, now electric field is in this direction, and
Yes, sir.
P is in this direction. P is in this direction. That means negative minus Q is here,
Yes,
and
sir.
positive Q is here. Okay,
Yes,
like
sir.
this. Then here we say theta is equal to theta is equal to theta is equal to how much? Theta is equal to 180 here.
Yes, sir.
Opposite direction, no?
Yes,
P and
sir.
E.
Yes, sir.
Then torque is equal to PE sine theta.
Fine.
Sine 180. Sine 180 is 0.
Yes,
So
sir.
torque is equal to 0.
0.
Then work done is maximum,
Yes,
that is equal to 2 PE.
2 PE. Yes, sir.
Okay. Cos 180 is minus 1. So,
Yes, sir.
okay.
Yes, sir.
So we get 2
2 PE. 2 PE.
2 PE.
Yes, sir.
And U potential energy is maximum, and that is equal to potential energy is minus PE cos theta minus PE cos 180. 180 is minus 1, so it is PE.
PE. Yes, sir.
Okay, now this we call it as unstable equilibrium.
Yes, sir.
Okay, this we call this as and
Unstable equilibrium.
unstable equilibrium.
Yes, sir.
Okay.
Yes, sir.
Right. This is equilibrium of dipole.
Yes,
So
sir.
one thing you have to remember is stable equilibrium, unstable equilibrium conditions.
Yes, sir.
Okay.
Yes, sir.
And next one is angular SHM. Now, in uniform electric field, if a dipole is slightly displaced, then it will make some oscillations. Okay.
Yes, sir.
From its equilibrium position, then it will make some oscillations, and the time period is equal to 2
2 pi
pi
root
root of
K
I
ideally M.
by P.
M. Oh, okay, sir.
Okay.
Yes, sir.
This is angular SHM.
Yes, sir.
So from its equilibrium position, if it is slightly moved,
Yes,
then
sir.
it will oscillate with the time period t is equal to 2 pi root of I
2
by
pi PE.
P.